Hi everybody, welcome back. We are ready for, drum roll, 8.3 hyperbolas.
That's right.
And this is our last lesson for Unit 4. Okay, so on our hyperbola, we're going to have the set of all points in a plane whose differences now of the distances to the two fixed points is constant.
Right.
So let's take a pause and see what that looks like on our little app that we have for you.
Definitely.
Okay, so the distance from any point P to F1 and then the distance from P to F2, when those are subtracted, in this case we're going to get 5. And notice they have an absolute value over here so that we can know that the absolute value, the positive and negative, doesn't matter.
Yep.
Okay, so let's go ahead and start drawing. And notice if I pause now, the distance is still 5. If I keep going.
So the segments change that make up the triangle, but they're changing together.
Correct.
Okay.
Correct. And in this case, from F1 to P is always bigger than F2, from F2 to P. Again, keep drawing. And then now, this is kind of interesting. If we switch them and make the distance from P to F2 larger, we get a whole nother branch of our curve.
Right.
So the hyperbola is actually created from these two red branches. Again, we could draw this horizontal or we could draw it vertical. And again, the distance, that constant difference, is 5. Okay. Now, Mr. Madsen, what do you notice about the foci versus any of the points, especially that one right there?
When compared to the ellipse?
Correct.
So one thing that you want to keep in mind is that your focus, the foci each are further out from the center as compared to the vertex.
Right. So I've stopped it right now. What would be that red dot would be a vertex. And that's what makes our shape look like it's going outward. Okay. All right. So let's get back into our notes here. Again, set of all points in a plane whose difference of distances from two fixed points is constant. What do we call those two fixed points?
Those are the foci.
They are.
I just want to say like race.
Okay.
All right.
Now, the kicker here is, since the foci are further away, we're going to have the relationship that C is going to rule everything.
Remember that C value is just distance from the center to the focus.
Right. And it's always the biggest. Now that's different from an ellipse. Okay. Now we do still have a Pythagorean relationship.
We do.
And this one is?
C squared equals A squared plus B squared.
So it's a true Pythagorean relationship because C is the longest.
Right.
Okay, we have a little bit of new vocabulary here. We're going to be talking a little bit about a transverse axis and a conjugate axis. Transverse is going to contain all those things that a major axis would have contained. And then the conjugate would be going the other direction.
Okay, gotcha.
All right, so let's take a look here. On a vertical hyperbola, we're going to have an equation with, notice that the y is first. So the only difference between the hyperbola and the ellipse is the plus and the minus in the middle.
Yes.
When you first look at the equation, you want to look for this minus in the middle.
Yep.
And that's what's going to make the differences of the distances and make us a hyperbola. That's hard to say 3 times fast. Okay.
That's right.
We are vertical when the y squared is first. Okay? If y squared is first, we're going to be vertical.
How does that differ from when we were vertical with the ellipse?
With the ellipse, we cared who was bigger in the denominator.
Okay.
And now we care which variable comes first.
Gotcha.
Because subtraction is not commutative.
Right.
Okay? The other thing that you'll notice is that the a squared is always first. And we'll get to that in a second when you talk about horizontal.
Okay.
So again, let's start with our definition.
Right.
Our distances here to the foci have to be subtracted.
Right.
And when we take d1 minus d2 or vice versa and the absolute value of that, we get a constant.
Okay.
Okay?
That's the definition.
That's the definition.
Right.
So this is going to be our center right in the middle.
Okay.
And again, you can probably guess by now what the center is going to be.
HK.
HK, there we
Right.
go. And you said that the distance to the foci was C, and you're absolutely correct. So this distance here is C.
Okay.
And this would be my first focus,
Right.
and here is my second focus. Remember, we don't touch the foci, we give them warm hugs.
Warm hugs.
But we don't actually touch them because they're germaphobes.
That's right.
Okay, the vertices then are touching the hyperbola. So this would be vertex 1 and vertex 2, and I'll mark it up here. This distance is now A.
Okay.
So you can see right away on the picture,
Yeah.
C is larger.
C is larger.
Okay?
All
In
right.
this case, our transverse axis is going up and down, And we don't have a conjugate axis drawn on here. We'll talk more about that when we get to the next
Right,
example.
right. So the same deal is that we're dealing with the negative is still here.
Yes,
And our equation still has a in the front, but there is
it does.
a difference in the variable.
Yeah, the x comes first.
The x comes first.
So on the horizontal, we have to have the x first.
Good.
Okay? So do we still have the same definition?
Yeah, we do. And we
Okay.
use the exact same definition. So we have our D1 here.
Great.
D2 being this length I'm talking about, the size of the triangle.
Yep. And it doesn't matter which one is D1 or which one is D2, because again, we're taking the absolute value of that
Right.
distance.
And so you can subtract either,
Yep.
and you still get the constant.
Still get the constant. So if those are the two distances,
Okay.
then those two big dots,
Yeah, these are going to be our foci.
right,
So just F1
sure,
and F2 is that
that's fine.
a notation. And again, we get this nice center here, center HK. And what's our length from the focus to the center then?
That's again C.
Okay.
So that's still the same. Difference now is that C is bigger
Right.
than the distance to the vertices. So where are our vertices going to be on this picture?
Okay, we're going to have our vertices here.
Yeah, our board's off a little bit, sorry.
And there, no worries, that'll work. And this, again, we can measure this length from the center to the vertex as length A.
Perfect.
Oh,
All right.
and of course our C squared
Right.
is equal to A squared plus B squared.
Perfect.
Cool.
Okay, so horizontal has the x first, vertical has the y first. They both have a subtract.
Awesome.
Great. So we're going to try an example here. I'll take the
Okay.
first one if you want.
Yeah,
I got some
that's
tricks
all
to
I
show
use.
you on the graphing
Yeah.
here. So again, when you see an equation, the first thing you should ask yourself is, first of all, what shape is it?
Right.
Second of all, is it horizontal or vertical? So Mr. Manson, what do you see?
Well, we got the negative, so we know we're dealing with hyperbola.
Yep.
And we got the x term leading the way.
Good.
So it looks like we're dealing with our horizontal.
Good. And that's the one you just talked about.
Right.
So we got a horizontal hyperbola. Now, here's where students mess up all the time. We do not care which denominator is bigger
No.
for a hyperbola. We
I
don't care.
No.
Who's first?
Right.
A is 3. B is 5.
Okay.
All we care about is who's first. Who's first is A. A comes first in the alphabet.
Right.
Okay, and that's what matters.
Okay.
All right, so we're going to need a center, some vertices, some foci. Okay, I've got my A and B. I got
Okay.
excited here. Let me jump back to my center here
Right.
real quick. Okay, we know I'm horizontal. The center is simply going to be at 1, -3.
Easy enough.
Okay, now I was helping a student the other day,
Yeah.
and she said to me, well, I know what the picture should look like. I just don't know how to list my vertices and foci.
Okay.
Who says you have to list the pieces first? Start drawing the picture.
Yeah, yeah.
That's great.
Yeah.
Okay, so vertices and foci. Now, if I am horizontal, is my x coordinate changing or is my y coordinate changing?
And so going from one horizontal point to the other,
Correct.
your x will be changed.
Very good. So for the vertices, I'm going to change by what amount?
A.
Correct. So I need to take my center, which is at 1, -3, and I need to add and subtract 3 to the x coordinate.
Okay.
So I'm going to be -2, -3, and I'm going to be at
4?
4, not
on
5.
On a good day. Yeah. All right.
And again, you can easily come over to the picture and count over 1, 2, 3, there's a vertex, and 1, 2, 3, there's a vertex.
Yeah.
Where am I? We're going to have you do these on graph paper, so use it.
Right.
Okay, so I've got my 2 vertices there. Foci.
Yes.
So I started to get excited with my A and B over here. We know that C squared equals A squared plus B squared.
Okay.
And so we're going to have that C squared is equal to, if I jump back up to my equation, look,
Right.
they're already squared right there.
Oh, nice.
9 and 25 is
That's clever.
34.
Mhm.
So C is simply the square root of 34.
34.
So the foci then will be, again, changing the horizontal only
Okay.
by the amount of the square root of 34. Well, that's pretty. Who came up with that? Lovely. Oh, wait, that was me. Okay,
All right.
so again, I'm going
From
to
the
take
center.
1
Right.
minus my square root of 34
Okay.
and 1 plus my square root of 34.
Okay.
Now, I don't actually need the foci to be able to create a picture.
Right.
Mr. Madsen was talking a little bit about that B value and how important that is.
Mhm.
So let's go back to this B value and the A value for our picture.
Okay.
Okay, the easiest way to graph hyperbolas is to use asymptotes.
Right.
And these are going to be slanted asymptotes. So we already know that this distance right here was 3. Okay, that would be in our transverse direction. Our conjugate direction, in other words, the other way,
Right.
is the other number. That's the 5.
5.
So all I got to do is count up 1, 2, 3, 4, 5,
And down.
and down 1, 2, 3, 4, 5. 5. We're going to pretend like that's actually lined up. Okay, now, there's not really a dot there. The red dots are not part of the picture.
Right.
But what they are part of is this little box that's going to create our asymptotes. So again, I went up and down 5.
Right, and then left, right 3 from the A value that you had earlier.
Correct. So
Okay.
this is 5.
Okay.
Okay?
Mhm.
All I got to do now, and by the way, if you took the time to connect this on the inside, looky what you
Hey,
get.
there's our old friend.
There's our ellipse.
Yeah,
That's
let's
not
get
what we're
rid of
doing.
that.
So if I go corner to corner on my box, which I'm going to try to do here, cross your fingers. That's pretty good. And corner to corner on my box, I missed the middle. There we go. Those asymptotes are going to guide the shape of that hyperbola.
Right.
Okay? Now, key feature.
You've
got to touch the vertices.
Mhm.
So I know that my hyperbola is going like this.
There you go. So that box, the corners really give you a good indication of how this hyperbola extends.
Is going to look. And the most common mistake is people get the box on their paper and then they're looking at it blinking because they can't remember, am I drawing it left and right?
Or
am I drawing it up and down? What am I doing? 2 things you can do. First of all, you identified it as horizontal.
Yeah.
It has to be opening side to side. You will touch the box. Wherever you touch the box should be your 2 vertices.
Nice.
Alrighty. So, Mr. Matson's going to
Okay.
give us another one to try. This would be a great time to pause that video
Yeah, give this one a try.
and give us one to try on your own.
This is center, vertices, and foci. That's a great place to start. So I'm
Okay.
going to start with the center there.
So the center, I see that there's a 2 with the X, or negative 2 with the X,
Oh,
rather.
see, so there you go. The X is on the right side. I should identify which way this bad boy is going.
That's a great idea.
Okay.
Let's start there.
So we know we have a hyperbola,
We do.
and the Y is in the lead. What does that tell me?
Oh, Y is in the lead. That Y is up and down. That's vertical.
Vertical. All right.
So we got a vertical.
Okay.
There we go. And so the X part of the center is going to be with the X variable.
Okay. So negative 2. I don't see any number with the Y.
Oh, that's a 0.
All right. Easy enough.
And could we go ahead and graph that if we wanted to?
Absolutely. Let's
Okay.
do that. All right. Vertices.
So if I'm going to do vertices, I need A, correct?
A, yes.
All right. Well, A is it bigger or first?
It's always first.
First. A is first. So the square root of 16 is 4. So my vertices are 4 units away from my center.
Right. Now, I'm shifting vertically, so that means
Oh. Vertically. So the Y coordinate
the
changes?
Y coordinate changes.
Okay, so how about negative 2, comma 4?
All right.
And negative 2, negative 4.
I like it.
And again, we're writing the vertices first because we're picturing it in our brain, but you are more than welcome to go to that center and go up 4 and down 4 and figure out where you are.
All right.
Yeah, our board's pretty off, so just trust us.
I'll take it.
Okay, so what else do we need?
Yeah.
It looks like we need some foci.
Yeah, absolutely. And to figure out that guy, we need the C. To figure out C, I need to identify my B value, yeah?
Right. So
Okay.
it's like a little puzzle, guys.
All right.
So B is 2.
All right, so we got A squared plus, I'm running, let's put the C squared. Is that
Sure. That's right.
All right. We're running with it. All right, so that means I'm looking for my C. C squared equals 4 squared plus 2 squared. How's that looking?
That's
so
great.
far?
And remember, you can do the 4 squared from the A and
Yeah.
B, or you can also look back at the equation because
Right.
that's going to give you the
That's what
16
they
and
are.
the 4. So how about C squared is 20, and C would be the square root of 20?
All right. And just a little something to keep in mind, the square root of 20 is going to be between the square root of 36, excuse me, the square root of 25
Okay.
and the square root of 16,
So somewhere between 4 and 5?
somewhere between 4 and 5.
Okay.
All
So
right.
somewhere between 4 and 5 units, if we wanted to, we could put that on our picture.
So yeah, I
That
could
the
do a quick
green
little
dots
guesstimation there.
Are the foci.
Yeesh,
Okay.
that one was a little off. but
Yeah,
we're
it's the
gonna go.
bottom of the picture that's off, sorry.
No
Now,
worries.
do we still need that B value of 2?
You know, it would help us with get the asymptotes.
Okay, so which way do we go for the 2?
Left and right.
Okay, so on a vertical, we're going to go left and right for the B amount, and on a horizontal, we'll go up and down for the B amount. That sounds an awful lot like an ellipse. Only this time, notice the 2 green dots, the foci, are outside of the box.
That's going to allow me to get some direction for
You're right.
this
They
guy.
can use a ruler, we can't.
Right.
So you guys got to figure it out here.
And
So there's our asymptotes.
all right. And I know I'm hugging my foci, which I
Okay.
was doing earlier. So I'm just going to go for it here.
Yep.
There
Nice.
we go.
We just want to keep getting closer and closer to our asymptotes.
All right.
So not so bad. One thing to notice about these asymptotes is that these are lines,
Mhm.
okay? So if we wanted to, we could talk about the slope
Oh, yeah.
of this line, this blue dashed line right here. We're making lots of pretty colors here.
I see. So our asymptotes are always lines.
They are lines,
Okay.
and so they will have slopes. So notice the up and down in this direction was the A,
Okay.
and the side to side was the B.
Oh, well, there's our slope.
Okay, and if we go back for a second on the last picture, the up and down was the B value, and the side to side was the A value. So that's another way to get those asymptotes with that box. All right, so the reason we're talking about these asymptotes and this whole up A and over B thing once again, okay, this is the one Mr. Madsen drew for us.
Right.
We went up A and over B for our asymptotes, is because again, when we're talking about a center of H comma K, okay, then an asymptote is going to have a slope involving that A and B. A vertical hyperbola is going to have an up and down transverse axis. It's going to look like that.
Right.
Ish.
Right.
Okay?
We'll take
and
it.
so its equation has to have a slope, which is an A over B in it.
Yep.
Okay? Now, if I think back to this equation of this line, this blue asymptote here, it touches that dot. In fact, both the asymptotes touch the center.
Right.
So if I think about point slope, I can simply do x minus h and y minus k for my transformation.
Nice.
One was positive slope, one was negative slope.
Oh, perfect.
So if they ever ask me for the equations of the asymptotes, there you go. Again, I'll stick with the vertical for a minute here.
Okay.
If the center was h and k,
Right.
on the vertices, what is changing?
The y coordinates.
All right, so what should our new vertices be?
So we keep h the same for each of them.
Okay,
And we're going to add, for the vertices, it's k plus a,
nice.
and then it's k minus a.
And again, those look like an ellipse because they work the same way. All right, foci.
On the same line, so we have the same x values.
Mm-hmm.
This time, the difference is going to be with respect to c. And
Correct.
we're going to add c to k and subtract c from k.
You said C, and I promptly did not write C.
No worries. We got
Okay.
it. There it
I was
is.
too busy trying to make sure my K looked like a K.
There you go. That's all right. We'll take
All right,
it.
so if we have a horizontal transverse, now our
Yes.
hyperbola is looking like that.
Okay. So again, from the center, we could talk about the asymptote.
So they're still going to go through the H and K, correct?
We're still going through h and k,
Okay.
so we can use that as our point in our point slope form.
Nice.
The difference is
The slope.
the slope.
The slope is going to be backwards. So now, if you look back at the picture I drew on the first example, we went up and down B and left and right A. So that's H. There we go. Okay, now again, horizontally, then the horizontal components of the vertices and the horizontal of the foci are going to change. So
Okay.
how about H plus A,
Okay.
comma K, and H minus A, comma K. We're still changing by A for a vertex.
I like it.
For a focus, we're still changing by C, so H plus C, and H minus.
Oh, that's easy.
And again, I honestly don't memorize these asymptote rules. I go back to the picture after I've drawn it, and that's what allows me to find my asymptotes.
Nice.
Okay,
Love it.
so I think it's your turn.
Okay. Let's tackle this guy.
Okay, so that was we started off with here's the equation, give us the stuff.
Right.
So now here's the stuff, give us the equation.
Ooh.
So what should we probably do first?
Should we graph the points?
We should always.
Yeah. All right.
Let's make a little sketch because we have to figure out is this horizontal or vertical. And again, complete sketch. I don't even care if there's a scale on there. Doesn't matter.
Right.
So we've got a 1, -4.
Oh, this might. I didn't realize. Then
That's
we're
right.
going 1, -10.
That's all right. Just go down some and draw an F. It's a sketch. It's just for
Okay.
you.
There's 10.
Okay? So we've
10.
got, there we go. So we got a focus is there at the bottom.
Okay.
There we
Yeah,
go.
let's label this stuff. It gets all crazy.
It does. And there's the center.
Okay.
And then we've got a vertex 1, -1.
All right.
Okay.
All right. Would you call it B1
Now
or
we're-
B2?
Doesn't matter.
Doesn't matter.
Doesn't matter. Notice they gave us a vertex on the top, but a focus on the bottom, and some of you are going to go, well, now do I have to go find the other focus or the other? No. Right. This is vertical now.
this is
Hopefully
vertical.
we're all seeing that.
So what's going to go first here?
Vertical is going to have a y first, so y minus k squared.
Thank you. minus.
Right?
Oh,
X
yeah.
minus h squared.
Right. I'll get the bottom here in a second.
Yep.
Okay. Equal to 1.
Equals 1. And then the bottom, A is always first.
Okay.
So A squared and B squared.
So we
A
need
is always first.
H, K, A, and B.
Correct.
Okay.
We do. I got excited.
Okay.
All right.
Hey.
So, hey, Mr. Madsen, we already have the center.
We do have the
So
center.
we already have H and K.
We already have HK. That's awesome. Okay.
Okay.
Good.
So why would they tell us a vertex?
Well, it's the vertex that leads us to the length A because, because of the definition.
Yeah, yeah. So if the vertex is at 1, -1, and the
Okay.
center is at -4, then wouldn't A be 3 units?
Yep. I think it would. I
Okay.
agree. I concur. All right. So A3, and then we need our B value.
We do, but we don't have any way to
don't
find
have
B.
that.
We don't have a box. We don't have
Right.
asymptotes.
Right.
But we do have a focus, which
Right.
is going to tell us C. Okay. So if I was at -4 and I went down to -10, my C would be 6.
6. So are those ever going to be negative?
No, they won't.
They're not. Okay.
They won't because they're distances. It's
So-
not like a P in a parabola, which can be negative.
6 squared is going to be equal to my 3 squared
plus a B
the
squared.
B squared, so we can find
Like
B.
it. So 6 squared is 36, and 3 squared is 9. So 36 equals 9 plus B squared.
Oh, this is
And if we
good.
subtract, we get B squared is 27.
All right.
And watch this cool trick. We don't even need B. We need B squared for the equation.
Plug it in, right?
Yep, plug it in.
All right, so we have y minus -4.
Good.
We have that squared over our A value of 3. And
Squared.
Squared. Thank you. Indeed. And then we have x minus h +1 squared over 27. We don't need to square him. We already
Right.
did that, basically.
Right.
All right, so let's just clean everything up here because that. All right, so y plus 4 squared over 9. Thank you.
You're
Minus x minus 1 squared over 27 equals 1.
Nice.
We'll count it.
Perfect. So that's our right the equation. Again, they could give you lots of different information. They might give you some information about a transverse axis. They might give you some information about a picture or some asymptotes. They're going to give you enough information. You have to trust the writers of the problem that they're going to give you what you need. Okay, and then we come to our last and very favorite question.
We'll let the pro handle this one.
Prove that this is a hyperbola.
Yow.
Yay, which means we have to.
We have to complete the square.
We do.
Factor, factor, factor.
We do. We're going to complete the square. So the first thing I'm going to do is I'm going to notice that I have a y squared and a y, and an x squared and an x, but notice that the y squared is first and positive.
Okay.
And for hyperbola, it matters. So I'm
Yes,
going to
it
put
does.
the y squared first. Okay? And that means I'm going to put the 50y next to that. And then if I change colors, because you know me, what did you say that one video?
Looks like a clown threw up.
Yes.
That's all right.
Yes. Let's call the clown Cofield and we are done. Now, we do need to tell you that we made a typo mistake. So please change for us now this right here.
Yeah.
That needs to be negative 54x. I'm not sure what gremlin typed the wrong thing, but you fix it for us, please. Okay, make sure it says 54.
Yes.
Okay, and then we're going to have equals, and I'm going to go ahead and bump that constant over to the other side.
Nice.
Okay, if you are not a pro yet at completing the square, please pause the video and try it again. Okay, so we almost have our hyperbola correct.
Yes.
That's hard to see. Okay. But we need to know that our hyperbolas usually equal 1.
Yes.
So what should we do?
Well, we got to divide everything by the 225 to get the right side to be 1.
Okay. But Mr. Madsen, when I type this in my calculator, then I start freaking out because I get some weird decimal.
Right.
How do I handle that?
Well, you don't put in your calculator at all. You just divide your fractions. 25 divided by 225. How many times does 25 go into 225? That should be easy enough.
Oh, that's 9 quarters and $2.25.
There
So
you
we're
go.
reducing.
Right.
We're just reducing.
That's all it is.
Okay. So that's over a 9. And then I have x plus 3 squared. And if I reduce again, I will get 25, will I not?
You will.
Equals 1.
Perfect.
Okay. So now we've done the prove part of this
We
question.
know it's hyperbola.
And we need to deal with the fact that they also asked us for a center. And they asked us for asymptotes. Okay, so center, when I'm looking at this equation,
That's easy enough.
center is going to come from these two numbers right here.
Yes.
There we go. So where will our center be?
So our x coordinate of the center is going to be the -3.
Okay.
And y coordinate +1.
Nice. Okay, and then we need to talk about our asymptotes. Now again, this is where I would not memorize. I would think if the y comes first, this is vertical.
Vertical.
It's doing something like this.
Okay.
And if it's doing something like that, then on my asymptotes, from the center up to this number is A. That's the vertex right there.
Okay.
This is a vertex, this is a center. That's my A amount, which we know is 3. Okay?
Okay, yeah. Yeah, so we know
A
our
equals
rise.
3.
If you think rise over run, you know the rise is 3.
Correct.
Okay.
And then the run of my slope, this
Uh-huh.
is, we're talking about slope of a line,
Yeah.
is going to be B equals 5.
Okay.
Okay, so now I'm ready to write my equations. I know the center, this is my transformation. So I'm going to have y minus 1 equals plus or minus. My A was a 3, my B was a 5.
Good.
And then x minus a -3 or plus 3.
Nice.
Most common mistake right there is people try to square it because they're used to stuff being squared.
If it's
These are
parentheses,
lines.
right.
These are lines, and they are asymptotes.
Nice.
Okay? Alrighty. Guess
It
what?
is.
That's it for lesson 8.3. That's it for unit 4.
We're
And
out. Mic drop.
it's also it for the first semester.
Well done.
We will see you in class.